The Voyager missions, which began over 4 decades ago, remain some of the most significant and enduring achievements in space exploration history. Launched by NASA in 1977, the twin spacecraft Voyager 1 and Voyager 2 were initially tasked with exploring the outer planets of our solar system. However, their journey has far exceeded these initial goals, continuing to send invaluable data back to Earth from the edges of interstellar space. The story of the Voyager mission spans over 35 years and 13 billion miles. It began in July 1972, when NASA initiated a project that would eventually lead to the launch of 2 spacecraft in 1977. These spacecraft were intended to explore the outer planets Jupiter, Saturn, Uranus, and Neptune. For nearly 5 decades, the spectacular Voyager space probes have explored our solar system and beyond, transmitting invaluable data back to Earth. However, the probe's latest transmission has been the most shocking. In the last 2 decades, NASA has officially disclosed that the Voyagers encountered an unknown force within the vast expanse of space, and the nature of this entity remains shrouded in mystery. What did the Voyagers find, and what prevented the spacecraft from transmitting this discovery immediately? Let's delve into these fascinating events. The Voyager spacecraft have transformed into incredible time capsules representing their era. These remarkable man-made space probes have boldly ventured beyond our solar system, charting new territories and delivering groundbreaking discoveries to scientists on Earth. Most people don't know that these spacecraft have a memory capacity that is 3 million times smaller than a regular smartphone and transmit data at a rate approximately 38,000 times slower than a 5G internet connection. Despite these limitations, these spacecraft, designed in the 1970s, are some of the most successful probes ever launched. In an unexpected turn of events, the Voyagers have made a recent discovery that has divided the scientific community. Many scientists hope that the data is a result of a malfunction rather than genuine readings. The strangest part of this incident was that it appeared like the probes had to conquer an extraterrestrial force to deliver this message to Earth. Before we delve into NASA's latest findings on this incident, let's take a closer look at these spectacular probes that have tirelessly observed the cosmos on behalf of our planet. These 2 spectacular spaceships owe their launch to a rare celestial alignment that takes place once every 176 years. In this specific instance, the 4 largest planets in our solar system played the role of guiding stars. These planets, Jupiter, Saturn, Uranus, and Neptune, created a cosmic gravitational slingshot effect that could boost a spacecraft's speed as it passed each giant planet. It was as if the spacecraft were being tugged along by an invisible celestial rope, propelling it forward with a burst of momentum. However, this alignment presented a major limitation as it took place only once in nearly 2 centuries. This rare alignment offered a golden opportunity for interplanetary exploration. To take full advantage of this celestial event, a spacecraft had to be launched in the mid-1970s to reach these distant planets, while the planetary lineup was still in effect. NASA seized this once-in-a-lifetime chance and created 2 identical spacecraft to embark on this epic journey. In a captivating display of cosmic exploration, Voyager 2 embarked on its remarkable journey from Cape Canaveral, Florida, on August 20, 1977, propelled by the Titan III E-Centaur rocket. On September 5, 1977, Voyager 1 followed suit, embarking on a twin odyssey into the cosmos. Their primary mission was to explore the gas giants of our solar system, Jupiter and Saturn, along with the moons that encircle them. Yet, these intrepid explorers far surpassed their initial objectives, embarking on a voyage that would carry them to the outermost regions of our celestial neighborhood. Voyager 1 and Voyager 2 have achieved numerous milestones during their epic journey. They have endured longer than any other spacecraft in history and ventured farther from Earth than any other human-made objects. In fact, they have crossed the threshold into interstellar space, making them the first human-created objects to achieve this feat. Their voyage into interstellar space, beyond the Sun's sphere of influence and into the uncharted expanse of the galaxy, has yielded invaluable data, leaving scientists astounded. As pioneering interstellar probes over 12 billion miles from Earth, they continue to surprise physicists with their discoveries. One such astonishing discovery is the recent warning from the space probes, confirmed by NASA scientists. We'll delve into that in detail shortly. The Voyagers stand out as extraordinary space probes due to their utilization of self-powered radioisotope thermoelectric generators, RTGs. These nuclear batteries, also referred to as radioisotope power systems, employ the Seebeck effect to convert heat from decaying plutonium into electricity. Remarkably, these RTGs operate without any moving parts, minimizing the risk of wear and tear and making them exceptionally well-suited for harsh and remote environments. These RTGs operate without any moving parts, minimizing the risk of wear and tear and making them exceptionally well-suited for harsh and remote environments. One notable advantage is that these generators are not dependent on solar energy, making them highly advantageous for deep space missions. However, there's a catch. As time progresses, the decaying plutonium in the RTGs gradually reduces their power output. Despite this, the overall mission has not been compromised thanks to the proactive measures taken by NASA engineers. They have strategically deactivated heaters and non-essential systems that do not impact the spacecraft's flight capabilities to compensate for the diminishing power supply. But the engineering efforts don't end there. The Voyager spacecraft was designed to use an 8-track tape system for data storage and playback. Here's how it works. First, the scientific instruments on board the Voyager probes collect various types of data such as images, audio recordings, and measurements, and convert them into a digital format. The digital data is then serialized and stored on the 8-track tapes, which feature 8 parallel tracks for efficient storage. When it's time to transmit the data back to Earth, the onboard computer sequentially reads the data from the relevant tracks. The read data is transmitted through the spacecraft's communication system, primarily utilizing its high-gain antenna to send the information back to Earth. On Earth, receiving stations capture and decode the transmitted data, preparing it for scientific analysis. The materials used in these tapes are specially designed to withstand the rigors of space. They typically comprise a metallic base layer made of materials like stainless steel, which is resistant to radiation, extreme temperatures, and the vacuum of space. Each track on the tape is coated with a magnetic material that stores the digital data, designed to resist degradation over time. The tapes are also encased in protective enclosures to shield them from potential damage sources like micrometeoroid impacts. The enduring functionality of these tapes is remarkable. Regardless of their old-fashioned design, they continue to operate and transmit data back to Earth every day. What are the notable achievements of the Voyager spacecraft? The achievements of the Voyager twin probes have been nothing short of spectacular. Their early observations of Jupiter and Saturn's moons, made over 40 years ago, astonished researchers and shattered previous assumptions about these distant worlds. These moons, once thought to be as inert and heavily cratered as our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, reached several significant milestones during its journey. As these spacecraft continue their remarkable voyage, NASA has implemented a series of measures to extend their operational lifespans. Over the past 3 years, non-essential components and heaters have been turned off to conserve energy, enabling them to operate well into the next decade with an estimated mission end date of 2030. For the scientists and engineers who have been part of this extraordinary journey since its inception, the culmination of the Voyager missions is a bittersweet moment. Their dedication and hard work have seen the project through far beyond their initial expectations. The data returned by the Voyagers has provided invaluable insights, fueled countless scientific discoveries, and inspired generations of researchers and space enthusiasts. Voyager 1 and Voyager 2 were not just ordinary spacecraft. They were meticulously designed to be stable platforms, with a rotation rate more than 15 times slower than the hour hand of a clock. This design minimized any visual blur as the spacecraft captured images and data while hurtling through space. Their impressive imaging capabilities began to astound scientists and the public even before their encounters with the outer planets. The spacecraft started transmitting images of Jupiter while still several months away from the planet. These early images, revealing the gas giant's swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly set the stage for the Voyager's groundbreaking observations. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in the solar system. The spacecraft's instruments detected peculiar signals from Io, which were confirmed by the vivid images they captured. These images revealed towering volcanic plumes and a surface marked by the ejection of volcanic material. Pele, one of Io's most prominent volcanoes, has erupted 30 times higher than Mount Everest, covering an area nearly the size of France. The Voyager spacecraft captured over 33,000 images of Jupiter and its moons, showcasing the planet's beauty and the incredible diversity of moonscapes in the Jovian system. Before the recent warning signals, the twin Voyagers had been making spectacular discoveries since their launch. One of the most surprising findings was the existence of Jupiter's rings. These rings, though faint, were a revelation and added to the intrigue of the gas giant. Additionally, Voyager 2 revealed that Europa, one of Jupiter's 53 named moons, possessed an icy shell believed to be over 60 miles thick. These findings challenged previous assumptions about the nature of these distant celestial bodies and inspired further investigations into the potential habitability of icy moons. As the Voyagers departed from Jupiter, they received a gravity assist that provided them with a farewell kick, propelling them towards Saturn. Without this vital boost, they would have been unable to escape the Sun's gravitational pull and venture further into space. Voyager 1 and Voyager 2 soon went their separate ways, each heading towards new frontiers. Voyager 1's path took it close to Saturn's moon Titan, which is cloaked in an orange hazy atmosphere. This moon's mysteries piqued scientists' interest, leading to multiple observations and discoveries. Voyager 2 continued its journey, passing Saturn in 1981 before heading toward the more distant Uranus and Neptune. These encounters marked the first and, so far, only close-up explorations of these ice giants. In 1986, Voyager 2 became the first spacecraft to visit Uranus. It discovered 10 new moons, 2 new rings, and a magnetic field that was both offset from the planet's center and tilted relative to its rotational axis. The spacecraft also observed the planet's unique blue-green color, resulting from methane in its atmosphere absorbing red light. Voyager 2's encounter with Neptune in 1989 revealed a dynamic world with the fastest winds in the solar system, reaching speeds of up to 2,100 kilometers per hour. The spacecraft discovered 6 new moons and observed the Great Dark Spot, a storm similar to Jupiter's Great Red Spot, but which has since disappeared. Voyager 2 also provided the first images of Neptune's largest moon, Triton, revealing geysers of nitrogen gas erupting from its surface. After completing their primary missions, both Voyager spacecraft continued their journey toward the edge of the solar system. Voyager 1 entered interstellar space on August 25, 2012, and Voyager 2 followed on November 5, 2018. These milestones marked humanity's first steps into the space between the stars, providing unprecedented data about this previously unexplored region. In interstellar space, the Voyagers have been measuring the density and temperature of plasma, ionized gas, and detecting cosmic rays and interstellar particles. The data collected by the spacecraft have helped scientists understand the boundary between the solar wind, a stream of charged particles emanating from the Sun, and the interstellar medium. A particularly fascinating aspect of the Voyager missions is the inclusion of the Golden Record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. This time capsule was intended to communicate the story of our world to extraterrestrials who might encounter the spacecraft. The Golden Record includes greetings in 55 languages, a variety of music from different cultures and eras, natural sounds such as thunder and birdsong, and 115 images depicting scientific information, human anatomy, and everyday life on Earth. The inclusion of this record reflects the hopeful and forward-looking spirit of the Voyager missions, symbolizing humanity's desire to connect with the universe. Although the Voyager spacecraft are now over 12 billion miles from Earth, they continue to send data back to NASA's Deep Space Network. Their power supply is diminishing, but engineers have carefully managed the spacecraft's energy resources to extend their operational lives as long as possible. It is expected that the Voyagers will continue to communicate with Earth until at least 2025, after which their power levels will be insufficient to sustain their instruments and communication systems. The Voyager missions have inspired generations of scientists, engineers, and space enthusiasts. They represent humanity's curiosity and determination to explore the unknown, pushing the boundaries of what is possible. The images and data sent back by the Voyagers have not only advanced our scientific understanding but also captured the imagination of people around the world. The iconic pale blue dot image taken by Voyager 1 at Carl Sagan's suggestion shows Earth as a tiny speck in the vastness of space. This image has become a symbol of our planet's fragility and the need for global cooperation to preserve and protect it.